Write the net ionic equation for a reaction between barium nitrate and sodium sulfate. So we're assuming that it's a double displacement reaction. So we're going to build and balance first, and then we'll start identifying solubility rules within that. So let's look at writing that out. So barium nitrate, let's see. Barium's way down in group 2. So barium nitrate would be BaNO3 plus sodium sulfate. Na2SO4. We're going to assume here that our reaction is double displacement. So we'll bring our cations and our anions and we'll switch them. So that would leave us with barium sulfate and sodium nitrate. And then, like when asked, we want to go ahead and balance our reaction now so that we know if we're going to have more than one of a particular ion. Okay, so I think just a 2 there, right? Yeah. Is that good? So now let's go through and start identifying, are they aqueous or are they solid? Nitrate. Most nitrate salts are soluble, so that means we're going to go aqueous. I hate when it says soluble. It makes me want to put the S. Yeah. Right, but it's S is solid.
You're like soluble. You don't put the S. I mean solid.
I know. It's still, even to this day, I feel like it's just so annoying because I really want to put it. But soluble does not mean solid. It means aqueous. So, most alkali metal salts plus ammonia are soluble. So sodium is an alkali metal, so this would be aqueous. Barium sulfate. Okay, sulfate salts. You know what it means when it says salt? That just means anything grouped in group 1 or 2 will bond to form a salt. So when it says that, it means it's grouped with 1 or 2. So barium is an exception to that, barium sulfate. So it will be a solid. And then sodium nitrate would be aqueous because it fits in rule number 1. Okay, so this means we are going to have a reaction that takes place. We are going to have a precipitate form. Do you feel like you need to write out the full equation, or can you go right to the net ionic equation? Go straight there. Okay, so going straight there means I'm going to identify the ions I need to form barium sulfate. So I would be left with a barium, which has a +2 charge, and I would be left with a single sulfate, SO4, which is a -2 charge. I should include that those two are aqueous because they are ionized at that point, right? They are dissolved in water. And when they react, they would form barium sulfate, which is a solid. Okay, and that's it. So we don't have to write out the complete ionic equation if you don't want to. We understand our spectator ions are nitrate and sodium on both sides.
Is the complete ionic?
Complete ionic would be just writing the middle step. Yeah, it would be writing barium +2 and +2 NO3 minus, right? It would be writing out all the spectator ions, and then you just kind of cancel the spectator ions that are on both sides. And whatever you're left with is your net. It would just be the middle step, like the work step to get to your final. Yeah. So I won't ever.
It's like you're never gonna ask.
I don't think I need you to do the complete. No, it just be as long as you get to the net. I think you're fine. Okay. Does that feel pretty comfortable? All right. Let's move. We're actually going to go back to a little stoichiometry, but with solutions. So this is going to feel comfortable to us because it's just stoichiometry, but we might have to use molarity equations to get us to moles, right? Or we might have to use that to help us get to moles. So it says calculate the mass of lead sulfate formed when 1.25 liters of 0.05 molar lead nitrate and 2 liters of sodium sulfate are mixed. So now we're mixing solutions. We're not just combining we're not just making a chemical reaction. We're actually combining a solution, okay, or two solutions. So I need to write my equation out first. I'm going to build and balance. Lead 2 sulfate would be PbSO4. Oh, no. I'm backwards. I'm already getting ahead of myself. Okay. 1.25 liters of lead nitrate is mixed with sodium sulfate. So those are my reactants. I accidentally looked here. This is going to be a product. So I'll have to wait on that one. So lead nitrate is PbNO3 Sodium sulfate is Na2SO4. It would form lead sulfate and sodium nitrate. Okay, and then I want to go ahead and balance here. This actually balances almost the same as our last one. I'd say actually exactly the same as our last one. The ratios here are the same. So we don't have to walk through an ionic equation here. We could, we don't need to. It's asking us about the mass. So I'm going to find the number of grams of lead sulfate here at the end. Lead 2 sulfate. Okay, I'm going to also write out what sort of information I have about my other ones. I know that I'm starting with a 0.05 molar and I have 1.25 liters. And then I've got 0.025 molar and I've got 2 liters of that. So I've got some information about my initial starting solutions. I'm going to mix them and figure out how much of my product can I make. Okay, if I had to guess, I would assume here that lead sulfate is a solid. Yeah. And so we actually are going to have a mass of that precipitate, right? That precipitate is going to be a solid, and so we can calculate the mass of that. If they were both going to still be solutions or still be aqueous, then we don't really need to find the mass of it, but we're going to look for the mass of our product here. So we're essentially doing kind of a limiting reactant situation, but we can go, we can find moles of each of them so we have a starting point. So I would use 0.05 molar equals moles over 1.25 liters. Okay, and I can find out how many moles are present in that lead nitrate solution. 0.0625 moles. Of PbNO3 2. And then in my second solution, I have 0.025 molar equals moles over 2 liters. So that would give me 0.05 moles of Na2SO4. Am I going too fast here, or are we hanging in there? Doing okay? So this gives me a starting point, at least for both of my solutions. I know how many moles are present. Now, here's my question for you. Do I need to run my calculation twice, or can I already identify the limiting reactant? Do I need to run the T-chart twice, or can I identify it? I think I can identify it, but why specifically? Let's take, which one do you think is the limiting reactant? Lead nitrate or sodium sulfate? Sodium sulfate. I would also agree that that's my limiting reactant, but how do I know that for sure without running the T-charts through? Okay, it has less moles, I would agree, but what's the other key factor? The key factor is that all of these mole ratios are the same. If they did not all have equal mole ratios, then we'd have to go mole ratio step, right? Or at least analyze through that. You wouldn't necessarily have to do it in the chart, but you have to analyze through that. Since all of those mole ratios are 1 to 1 to 1, and we're not concerned with this guy over here that doesn't have a 1 mole ratio, we are able to just quickly identify which is my limiting reactant, right? I'm going to run out that first. If the mole ratio was not 1 to 1 to 1 for everything that we were looking at, then I think it would be encouraged to go ahead and use your T-chart, but we don't have to. So now that we know this is a limiting reactant, we can go ahead and just convert that to grams of PbSO4 just with a regular T-chart. Okay, so now we can just go true stoichiometry here. So 0.05 moles of Na2SO4. We're going to go mole to mole, and then moles of lead sulfate to grams of lead sulfate. Okay, so this middle step's my mole ratio step. We know it's 1 to 1. And so I need the mass of lead sulfate. Before silver nitrate is the compound that leaves little black spots on your hands, right? And so we've used that as our a limiting reactant lab before.
That's the one you spilled on yourself.
That's right. Okay, the balancing here is simple, right? Everything is ones. My overall goal is to look for the mass of that. I was given some information about about silver nitrate. So 0.1 molar, and I have 1.5 liters of it. And it says we want to precipitate the maximum amount of AgCl. It's not asking us how much silver chloride we can make. We just want to make the maximum amount, if that makes sense. So that means I want to use up all of the sodium nitrate present. So essentially we want these both to be limiting reactants. Does that kind of make sense? We want to put in just enough salt to use up all of this to be able to make my product. So they'll both be limiting reactants here. But let's go ahead and see what we need to do. Any ideas on how we should start with that? I'm going to go moles here, right? I'm going to find out how many moles of this one do I have present. So 0.1 molar equals moles over 1.5 liters. Okay, gives me 0.15 moles of AgNO3. And so I want to look at it, if I have 0.15 moles of AgNO3, how many moles of sodium chloride do I also want? I want 0.15. I want the same because they are 1 to 1. So if I have 0.15 moles, I also want 0.15 moles of NaCl. And then I can just convert that to grams. Moles to grams, right? The key part in this question was really understanding that I wanted AgNO3 to be my limiting reactant. I want to use up all of it. And so I'm able to do that by pouring in, so much salt that goes with it. So 1 mole is 58.5, I think, is the molar mass of salt. Maybe I'm wrong about that, but I think it's somewhere close. 8.78 grams of NaCl. Okay, so that means if we started with this solution, I would dump in this many grams, and that would mean that I'm actually using both of them completely up. They would both be considered limiting reactants there. And so that would form the maximum amount of my product. Okay. Could I have dumped in 10 grams of salt? Yes, but I still would have only used up 0.15 moles of AgNO3 because that's all that there was available. So this is kind of the minimum amount that needed to be added so that they would both work out. Okay. That one was a little tricky in terms of what it was asking, right? But does that language seem clear? Okay. Why don't you try this last one on your own? 10 mils of a 0.3 molar sodium phosphate solution reacts with 20 mils what precipitate will form, and what mass a precipitate will form. So you're going to find the net ionic equation, or at least you don't have to write out the net ionic equation. Figure out, well, you have a solid, and then you're going to figure out the mass of that solid that will form. Okay, so build and balance, figure out what your solid's going to be, and then that's what you want to take your limiting reactant question to.
Pardon the interruption.
Why is this one so big?
Is it pretty bad? Lead itself's like 200. Okay. Molar mass, I had it at 811.6. Is that what you had? Okay.